Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 6.19 coming from section 6.4. It says use the power series to solve y prime equals 2y when y of 0 is equal to 5. So we have an initial value problem, a differential equation with an initial condition, and they're asking us to use power series to solve for this. Before we do that, though, let's make a note for ourselves, and because this is something that we've done before, this differential equation has a solution that we can actually solve for. This is a separable differential equation, and we can separate it by saying dy dx equals 2y. This is a y, sorry, 2y. And then so dy over y is going to equal to 2 dx. And then we can integrate both sides and get our results. So we will have ln of y equals 2x plus c. And then so we take the antiderivative, or we took the antiderivative already. We'll solve for y. And this is e to the 2x plus c, which is e to the c times e to the 2x. And I think we better known that as some other constant instead of e to the c. We'll just call it a times e to the 2x. So this is our solution to our differential equation. And we hope to come up with the same results when we do this using power series. So if we're going to approach this using the power series, we will write the power series for y, our solution, and we'll assume that our solution will be equal to some power series and goes from 0 to infinity of some c sub n thing times x to the nth power. So what is that? This c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x cubed, c sub 4x to the fourth, and it goes on forever, so maybe I'll stop there. And we want the derivative of this because that is going to be part of our differential equation. So taking the derivative of this term by term will give me the derivative of c sub 0 is 0. And then the derivative of c sub 1x is just c sub 1. Derivative of this is going to, the next term is 2c sub 2x to the first power, and then I will get 3c sub 3x to the second power, 4c sub 4x to the third power, etc. And so I can fill that out as much as I want to. I will leave it like that for now and move on to writing this into our differential equation. So our differential equation is y prime is equal to 2y, and y prime is equal to c sub 1 plus 2c sub 2x plus 3c sub 3x squared plus 4c sub 4x to the third plus dot dot dot. And that's supposed to equal to 2 times y, which is the original c sub 0 plus c1x plus c2x squared plus c3x cubed plus c4x to the fourth plus dot dot dot. So now we will kind of set them equal to each other. Let's simplify this just a tad bit. This is 2c sub 0 plus 2c1x plus 2c2x squared plus 2c3x cubed. I'm going to stop here, and now I will combine like terms, or set the like terms equal to, or set the coefficients equal to each other. Okay, we have a constant term c1 equal to the constant term. This is the only constant term on the other side. So we're going to have c1 is equal to 2c sub 0. Now the next is going to be the linear term, and the linear term is going to be 2c2 on the left side. The linear term on the right side is going to be 2c1. Okay, the quadratic term on the left side is going to be 3c3, and that is going to equal to the quadratic term on the right side. That's 2c2. And then let's take the cubic term on both sides, and that's 4c4, and that's equal to 2c3. All right, now we know that this is going to go on forever, but we're hoping to catch any information here to be able to get us to find a pattern for the C's. For the first one, it's just C1 equals 2C sub 0. Okay, that's fine. Nothing we can do there. Next one, we have 2C2. I'm going to not simplify this, but I will get C2 by itself. This is 2 divided by 2. I know that's equal to 1 times C1. I know that 2 divided by 2 is equal to 1, but just for the sake of being able to come up with a formula for this, I might want to leave it as raw as possible so that I can find a pattern. Okay, C1 is actually C2 times C sub 0, so this is 2 divided by 2 times 2C sub 0. Now this is C2, and I see a bunch of 2's here, but I'm going to hold off to try to figure out what the pattern is until I do, maybe 1, maybe 2 more. Now I will have C3 is equal to 2 over 3 C2, so that's getting C3 by itself. And C2 was equal to this thing, so I have 2 over 3 times C2, which is 2 over 2 times 2C0. So here I'm starting to see a bunch of 2's that would go up in the numerator, and I'm seeing 3 times 2 in the denominator. Okay, so that part is going to be important, as you would imagine. The next one is C4, and that would equal to 2 over 4, which I'm not going to simplify, times C3. So that's 2 over 4 times C3 was the one that we just found before, so that's 2 over 3 times 2 over 2 times 2 over 1 times C sub 0. Okay, so I think I'm getting more confident about the series that we have, about the patterns. And I will consider this 2 times this 2, so the numerator 2 will have a 2 squared over 2 times C sub 0. All right. Now the next one will have 2 times 2 times 2, so that's 2 to the third divided by 3 times 2, which I'm feeling this to be a factorial. It doesn't have a 1, but you know that it's a kind of implicit, so that's like 3 factorial in the denominator. And we can finally get that verification when we have 2 times 2 times 2 times 2, so that's 2 to the fourth, and then we have 4 times 3 times 2, so that looks a lot like 4 factorial now, just like this up here would be 3 factorial. So we have 2 to the fourth divided by 4 factorial times C sub 0. So they all have a C sub 0, which is another goal in our problem solving here. All right, so now we can have our y. Let me rewrite y again. That's C sub 0 plus C1x plus C2x squared plus C3x to the third plus C4x to the fourth plus dot dot dot. All right, we have C sub 0. Well, there's nothing to change there. C sub 1 is equal to 2C sub 0 x, and then C sub 2 is 2 squared over 2 factorial C sub 0 times x squared. C sub 3 is equal to 2 to the third over 3 factorial. Remember, this is going to be written as 3 factorial. C sub 0, and this is multiplied by x to the third, and our last term, at least the ones we have listed, is going to be 2 to the 4th over 4 factorial times c sub 0 times x to the 4th. So when we factor out, it looks like we're going to want to factor out a c sub 0 here. C sub 0, we're going to have a 1 left over there. And we're going to have a 2x left over for the next one. We're going to have a c gone here. This is at 2 to the 2nd power, x to the 2nd power. So we can really just write that as 2x to the 2nd power over 2 factorial. And c's gone. We got 2 to the 3rd, x to the 3rd, so that's 2x to the 3rd power over 3 factorial. And we can go on here, etc. 2x raised to the 4th power over 4 factorial, and then you can see the pattern from here. In fact, we can write it down. We got 2x raised to the nth power over n factorial. All right, great. That is our solution. Now, if that looks familiar, that is because this is the same thing as e to the x. Oh, let's hold off on that information and carry on with the initial conditions. So the initial conditions tells us that when x is equal to 0, y is equal to 5. So using our initial conditions, y of 0 is equal to 5. We're going to put 5 in for x, and then we're going to put 5 in for y and 0 in for x. So this is c sub 0, 1 plus, now this is going to be 2 times 0, and everything else has an x in there. So everything else will have zeros all the way through. So all that stuff disappears. And it looks like your c sub 0 is just going to equal to 5. And that is your unknown constant. Had we solved for that up here in the beginning, we would have gotten a is equal to 5 as well. All right, so then your final solution, y is equal to 5 times 1 plus 2x plus 2x squared over 2 factorial x squared. Oops, the x is already in there. Sorry. Plus 2x to the 3rd over 3 factorial plus 2x to the 4th over 4 factorial. And again, if this series looks familiar, it is exactly the exponential polynomial series. E to the x is equal to 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial, etc. And instead of x, you just put in the 2x. So in short, your answer is going to be 5e to the 2x. Okay, that's it. That's how you solve a differential equation using power series, and we're even able to relate it to a closed form function that would have been our solution. I hope that helps. Good luck.